Hey everyone, have you ever wondered what it really means to be fast? Today, we're going to dive deep into the science of speed. We'll start with a super simple formula, one you can actually test in your living room. And then we'll get into the wild, mind-bending physics of breaking world records. So, here's the plan. We've got 5 parts. First up, what even is speed? Then, we'll look at humanity's obsession with going faster and faster. After that, get ready to become a scientist right in your own home. I'll show you how. Then we'll learn how to actually see a journey just by using data. And finally, we'll leap from old school stopwatches all the way to satellites to see how speed is tracked today. Okay, let's do this. First things first. What exactly is speed? So let's kick things off with a question that seems almost too simple. We all use the word speed every single day, right? But what's actually happening when we talk about it, from a physics point of view? Well, in the world of physics, the definition is actually super straightforward. Speed is just a measure of how much distance an object covers in a certain amount of time. That's it. Think about it. How far did you go and how long did it take you to get there? That simple relationship, well, that's your speed. And here's a perfect example of that idea in action. You just look at this motorcyclist and you know they're moving fast. But why? It's because our brains are doing this lightning fast intuitive calculation. They're covering a ton of distance in a very, very small slice of time. Okay, so how do we take that feeling of being fast and turn it into an actual number? Well, we use this simple but honestly incredibly powerful equation. Speed equals distance divided by time. That's the secret sauce. This one formula, it's the key to measuring absolutely everything, from a snail crawling across the sidewalk to a rocket blasting into space. All right, we've got the formula down. So now let's see what happens when we humans take that simple idea and push it to the absolute bleeding edge. This is where we get into the quest for speed. And speaking of rockets, yeah, this is pretty much what happens when you decide to strap 2 massive jet engines to a car. What you're looking at is the Thrust SSC. It's a vehicle that was designed with one and only one purpose in mind, to be the fastest thing on wheels, period. So just how fast did it go? Get ready for this, an absolutely mind-blowing 1,223.66 kilometers per hour. To really put that into perspective for you, when driver Andy Green set that record back in 1997, he didn't just break the land speed record, he broke the sound barrier on the ground. But what's so cool about this is seeing the progression, It's just relentless. Every single entry on this list was the absolute peak of engineering at the time. And look at the dates. In just a couple of decades, huge leaps in jet engines and aerodynamics sent that record soaring. It wasn't just about genius engineering either. Imagine the sheer guts it took for those drivers to get behind the wheel. Okay, that stuff is just wow. But let's bring it all the way back down to earth for a minute. For our next section, we're building your own speed lab, and I'll show you how you can measure speed with some really simple tools you probably have at home. Yeah, you don't need a jet engine to start exploring speed. Seriously, all it takes is something like this, a simple ramp, a toy car, and a stopwatch. This is real physics, and you can do it right there on your kitchen table. And the experiment itself is super easy. So first, you set up your ramp at a certain angle. The important thing is to keep it consistent. Then you put the car at the very top, get your stopwatch ready, and let it go. The second it hits the bottom, you stop the watch. Now, here's the most important step, the one that makes it real science. You do it again. A few more times, actually. That helps average out any little mistakes and gives you really solid data you can plug right back into that speed formula we talked about. Okay, so we know how to calculate speed and get a number. That's cool. But what if we could actually see speed? What if we could see a whole journey laid out in front of us? Well, that's exactly what we're going to do next, by learning how to read the shape of a journey. Which brings up a really interesting question, right? How do you see a journey? I'm not talking about a video, I'm talking about using the raw data. How do you turn a bunch of numbers into a story you can actually read? The answer is something called a distance time graph. And let's start with the simplest one. If you see a totally flat horizontal line like this one, what's it telling you? Well, it means time is ticking by, but the distance from the starting point isn't changing at all. So the object? It's completely still. Its speed is 0. Okay, but what if the line is straight, but it's sloping up? Now we're talking. This shows that an object is moving at a steady, constant speed. And here's the really cool part. The steeper that line is, the faster the object is going. It just means it's covering more distance in the same amount of time. And this is where you can really see the story come to life. Look at this graph. For the first 2 seconds, you see that steady upward slope, so our object is moving. But then, bam, the line goes totally flat. Time is still moving forward, but its distance isn't changing. It's stopped. See? This graph isn't just a bunch of data points. It's the whole story of that journey. All right, we've gone from a simple toy car experiment to reading graphs. Now, let's take a massive leap forward. For our last section, we're jumping from the simple stopwatch all the way to the cutting edge, high-tech speed tracking.
So you might be wondering, why can't we just use a stopwatch for, everything? Well, it all boils down to one simple problem. Us, humans. Our reaction time, even if you think you're super fast, introduces tiny little errors. And when you're talking about world records or even traffic enforcement, close enough just doesn't cut it. That's where electronic timing comes in. It takes the human error right out of the equation.
And the tools we have today are just incredible. In a science lab or at the finish line of a 100-meter dash, you've got light gates that use an invisible beam of light. On the road, there are radar guns that bounce radio waves off cars for an instant speed rating. But for the absolute most impressive speed tracking technology, you gotta look up. Way up. That's right, we literally measure speed from space. You have this whole network of satellites orbiting the Earth, and they can pinpoint the exact location of a tracker on, say, a car. And then, using these unbelievably accurate atomic clocks, they measure the time it takes to get from one point to the next. The result? They can calculate speed with a level of precision that would have sounded like science fiction just a few decades ago. So, after all that, what are the main things to remember? Well, first, that super simple and powerful formula. Speed is just distance divided by time. Second, that you can actually read the story of a journey just by looking at the shape of a distance-time graph. And finally, just how far we've come, from the simple click of a stopwatch to the incredible, mind-boggling precision of atomic clocks in orbit.
And that leaves us with one last, really exciting thought to chew on. Now that we can measure speed with this insane level of accuracy, what's next? What do you think is the next great speed barrier that we, as humans, are going to break?